Hi guys, uh, I'm going to discuss few questions today. Some questions from section 2.4, 2.5 and 2.6. Now let's focus on this question. This is related to section 2.4. Fx equals to 4x square divided by x square minus 4x minus 5. We want to sketch the graph of that. I gave you these steps. If you cannot remember them, write it down and keep it handy at the time of exam. For this we have to find y-intercept, x-intercept, vertical asymptote, horizontal asymptote, slant asymptote. I'm reading everything because I'm writing in shortened form. You have the printed one with you. Check if fx intersect horizontal asymptote or slant asymptote too. We discussed function could never intersect vertical asymptote. It could, but it could intersect horizontal asymptotes or slanted asymptotes. Then number 6 is okay if you check it or not, but it makes convenient if it has symmetry. Number 6 is symmetry. If it has symmetry, we can do only half of the graph, and the other half is same as other half. We can create it using the half we did using the symmetry. Number 7 is very important. Check values or sign analysis. For this, these are the points you have to include. You have to include x-intercept, vertical asymptote, intersection points of function, if any. Sometimes the function never intersect horizontal asymptotes or slanted asymptotes. But sometimes the function does intersect those. Then with that we can, as number 8, step 8, we can sketch the graph. Okay, let's see how we find this. Y-intercept, we know we can find y-intercept when x equal to 0. That means f0. When you substitute 0, you see the numerator is 0. 4 times 0 divided by 0 minus 4 times 0 again 0 minus 5, you get 0 over 5, negative 5. Anything 0 over anything is equal to 0. That means y-intercept is 0, 0. That means graph go through the origin. X-intercept, for x-intercept you set fx to 0. When you do that, see fx is 0 equal to 4x square divided by x square minus 4x minus 5. Then for this to be 0, the numerator should be 0. For this to be true, 4x square equal to 0. This means x equal to 0. Again we get the same thing. Now if you substitute x0 here, again we get fx0, so which means it's x-intercept, y-intercept, both the same point, which is origin, 0, 0 point. Right? Vertical asymptote. For vertical asymptote, we set denominator to 0, okay, let's do this. We want to sketch the graph. Let's factor this out. 4x square divided by x minus 5 x plus 1 when we factor this. Now if you set denominator to 0, we get x minus 5 x plus 1 equal to 0. This gives us arrow means this implies x equal to 5 or x equal to negative 1, right? So these are the vertical asymptotes. Now horizontal asymptotes or slanted asymptotes. Now let's use the short method. It's the degree on the numerator and denominator both the same, therefore there cannot be any slanted asymptotes, but there could be horizontal asymptote. How we find the horizontal asymptote? If the degrees are the same on numerator and denominator, the ratio between their coefficients, x squared times coefficient, which is 4 over 1. If this question has no slanted asymptote, this no horizontal asymptote is y equal to 4 over 1, which means y equal to 4. Check if fx intersect horizontal asymptote or slanted asymptote. In this case there is no slanted asymptote. For this, let me erase this part. I'm gonna do this part on the top. 7 and 8, 6, 7 and 8. Horizontal asymptote is what? Y equals 4, right? To find the intersection point, we have to solve this equation and this equation. I number this 1 and this is 2. When they intersect, its y value, here y is fx, here y is y, they should be the same. When fx equal to y, their right sides, the right side of this equation should equal to the right side of number 2. Okay, let me do 4x square over x square minus 4x minus 5 should equal to 4. If you divide both sides by 4, this to this cancel out. This is 4 over 1. Cross multiply, we get x square minus 4x minus 5 equal to times, here it is 1, x square times 1 is x square, minus x square on both sides. This cancel out, and we get, this implies x equal to negative 5/4. I divided that number, it is negative 1.2, negative 1.2. We can use this as negative 5/4, but to make it short, I write it as negative 1.2, right? Okay, I write down what we found here. I erase this calculation part. We have x-intercept and y-intercept, they both 0, 0. Vertical asymptote x equal to x equal to 5 or x equal to negative 1. Horizontal asymptote y equals to 4. We found fx intersects horizontal asymptote at negative 1.2. Fx cross horizontal asymptote when x equal to negative 1.2. Okay, number 6. What's number 6? Symmetry. Now you know how to find symmetry. You find f of negative x, and if f of x equal to f of negative x, you say it is symmetric around y-axis. If f of x equal to negative f of x, f of negative x equal to negative f of x, you say it has origin symmetry. Refer your notes about that and substitute f of negative x here. Do it yourself and you will see this has no symmetry. This has no symmetry. Now we come to the important part, which is checkpoints. So I make the table already, so I'm gonna put it on the board. Negative, we have horizontal asymptote at negative 1.2. What I'm writing here is x values. This is negative 1, 0, -1 we have vertical asymptote. Again we have 5 vertical asymptote. X and Y intersect at 0. This one vertical asymptote at 5. At -1 and 5, Y value I'm writing here, it is undefined, I write infinity in short. When X is, these are X values and these are corresponding Y values. When X is 0, Y is 0. If you substitute -1.2 in here, we have horizontal asymptote, which is X equal to, horizontal asymptote Y equal to 4. That means when X equal to -1.2, Y value should be 4. Right. Now we want to substitute values in these regions. Now here and here we want to find if this Y value, when you substitute X value somewhere here, if it is greater than 4 or less than 4. Right. Substitute the number. I already substituted. To make it short, I write the answer here. In this region, this is fx is less than 4. In this region, it is greater than 4. In this region, it is left to 0. It is less than 0. In this region again, it is less than 0. We did this in class. To find the number here, you substitute any number less than -1.2. You may substitute -2 here. In between -1 and -1.2, you may substitute -1.1. Right. Likewise, substitute and find. Here you need the sign. Here, this is the horizontal asymptote. We want to know which way it is going. You may write the number. You may substitute a number and find number. Anyway, we just want to find and 4. Right. Now with this information, I'm gonna do the graph. I need some space, so I'm gonna write these Y values up here for infinity. When X is 0, Y is 0. This is wrong. This is infinity again. Alright. These are X values, these are Y values. Now here I'm going to do the graph. -1 and 5. This is X. We have vertical asymptotes. We have horizontal asymptote at Y equals 4. Now -1.2, in fact this value crosses horizontal asymptote at x equal to negative 1.2 should be somewhere left to negative 1. That means, say this is negative 1.2. The graph should go through this point. Graph should go through this point. X-intercept, Y-intercept both same. It should go through this point. Now this is all we know. Now the rest we get it from checkpoint. When y-intercept, I mean this is a vertical asymptote. When it is vertical asymptote, you know, graph maybe come in this way or this way, right? We did this, and now you may notice or realize why we did this. I did this in order to find if it is come from top or bottom. Now left to negative 1.2 means on this side y value is less than 4. This is y4. It is less than 4 means somewhere here. On the right side of 4 it is greater than 4. That means it is somewhere here. And we found it is crossing this point, therefore, and this is a vertical asymptote, x equals negative 1, therefore graph should go like this. And it cannot go down or come back, since this is a vertical asymptote, you know, it cannot come back and get closer to negative 1 because this is a function. Then it fails the vertical line test. And remember, this is a horizontal asymptote. The only possibility is it will go up again, getting closer and closer to y equals 4. Now with x equals 0, left side of 0 it is less than 0, that means it is below the x-axis. Right side of 0 it is again less than 0, that means in both sides is 0, therefore the graph should be go like this. This is getting closer and closer to negative 1, and we know x equals 5 is a vertical asymptote, therefore this should go like this. Now how about right side of 5? Here fx is, if you substitute a number, I substituted and already found in this region it is greater than 4. These are fx values. The fx value is, it means if you substitute number 6 here, you get a number greater than 4. Where you substitute 6? You substitute maybe here or here, right? You get a number greater than 4. That means when it is greater than, when x is more than 5, your fx value is somewhere here, anywhere above this y equals 4. That means this graph cannot come in this way. It cannot. Instead, the graph should come this direction, and since this is a horizontal asymptote, it should go parallel to this, means getting closer and closer to y equals 4 line. This is y equals 4 line. This is the x-axis, this is the y-axis, right? So now in one time when you look at this explanation, it may be too clear to you. Write it by yourself. Follow this instructions, follow these steps, and write it down. Maybe first time blindly, look at the video and write it down blindly, and follow these steps. Keep those steps that I gave you to draw or sketch rational functions, and try to follow it. First, if you do not understand, write it blindly. Second time, that will make sense, guarantee. Third time, you know it definitely, right? Okay, let's see another question. Can I erase this? I selected another question. X cubed plus 5x squared minus 4x minus 20 divided by x squared plus 3x. Now, even with the previous question, you saw we factored that, right? Here too, before you follow those steps, factor this out, but do not cancel. If anything, cancel from numerator to denominator. Do not cross them out, leave it as it is, right? Because those cancelling points are holes. You may cancel them after you make a note that there will be a hole there, but not in this case, right? Okay, let's factor this. Now on top we see we have 4 terms. We may wonder if we can factor this by grouping. So let's take first 2 terms together and last 2 terms together separately. From first 2 terms, if you take x out, we get x plus 5. If you take negative 4 from second 2 terms, you get x plus 5 divided by x is common, x plus 3. Then factor this out, we get x plus 5 times x square minus 4 divided by x times x plus 3. This thing again we can factor out. X plus 5, this is x minus 2, x plus 2 divided by x times x plus 3. Right, so I factored that out. Now I'm gonna erase this step and write this factored form up here. plus 5 x minus 2 x plus 2 divided by x times x plus 3. Alright, I copied it here, so I'm gonna erase this. Let's follow those steps. Number 1, y-intercept. For y-intercept we set x to 0, f0. When you substitute 0, we get 5 times negative 2 times 2 divided by this 0 times 0 plus 3. Right, you see, with this multiplying with this 0, whole denominator is 0, therefore your y-intercept does not exist. Does not exist. That means there is no y-intercept. Second thing, x-intercept. For x-intercept we set fx to 0. Can we get, when fx is 0, 0 equal to, I write this factored form, x plus 5 x minus 2 x plus 2 divided by x times x plus 3. Now look at this, we have fraction equal to 0. If a fraction equal to 0, we know definitely its numerator is 0. This implies x plus 5 x minus 2 x plus 2 equal to 0, and this gives us x equal to negative 5, positive 2 and negative 2. These are the x-intercept. So I'm gonna erase this part to get some space. We can find the vertical asymptote for number 3. For vertical asymptote, we set denominator to 0 times x plus 3 equal to 0. This gives us x equal to 0, which means y-axis, and x plus 3 equal to 0. This gives us x equal to negative 3. So what we found, no y-intercept, x-intercept, negative 5. From this we can write negative 5 0 2 0 and negative 2 0. We also found it has vertical asymptote, two vertical asymptotes, x equal to 0 and x equal to negative 3. Alright, I'm gonna use this. Now we found vertical asymptotes. How about horizontal or slanted asymptotes? Look at this. It has, look at the degree of numerator and denominator. Degree on the numerator is higher. That means there are no horizontal asymptote, but there could be slanted asymptote. You remember we discussed in one of the videos how to find the slanted asymptote. You divide the numerator by the denominator. You may use long division or synthetic division. X cubed plus 5x square. No, you cannot use synthetic division. You can use long division. Minus 4x minus 20 divided by x square plus 3x. X cubed divided by x square is x. We multiply both terms. X cubed plus 3x square, subtract, we get 2x square bring these two down, minus 4x minus 20, divide 2x square by x square, we get plus 2, multiply 2x square, 2 times 3 is plus 6x, subtract 10x minus 20. Right? Now this is the quotient and this is the remainder. Now I'm gonna erase this part and write the answer. This is the quotient. I'm gonna keep this part and the remainder. I'm gonna erase this middle part. Therefore we can write fx as x plus 2. When we divide this by x square plus 3x, x plus 2 is the answer, and the remainder is this negative 10x minus 20 out of what? X times x plus 3, or x square plus 3x, x square plus 3x. Same thing we can write as x plus 2. If you take negative sign out, negative 10x plus 20 divided by x square plus 3x. So here we found slanted asymptote. What is the equation of slanted asymptote? This part, y equals x plus 2. When x going to infinity or negative infinity, this part becomes 0, and function just behaves like x plus 2. Therefore y equals x plus 2 is a slanted asymptote. Again, if you check the symmetry for this question, do it, find f of negative x, and you will find there is no symmetry for this question, right? No symmetry. No symmetry. Then we can do the sign analysis or checkpoints, finding checkpoints. I'm gonna erase this part. Before that, I'm going to write down the slanted asymptote. We have slanted asymptote at y equals to x plus 2. Before you do the sign analysis, we can check if this intersect the slanted asymptote. Equation of the slanted asymptote is this. Now I'm gonna erase this part. You see, when we divide numerator by denominator, we get this answer. Now this is our fx. Equation of the slanted asymptote is this. If they are intersecting, this y should equal to fx, right? Then that means left side of this equation equal to the left side of this equation at the intersection point. Therefore right side should equal to the right side. This is what we're doing. We set right side of this equal to this right side of this equation. If it gives us sensible answer for x, we say okay, they are intersecting. If it does not give you sensible answer for x, we say they're not intersecting, right? Okay, let's equate right side of this equation to right side of this equation. Right side of that equation is x plus 2 equal to x plus 2 plus negative 10x minus 20 divided by x square plus 3x. If you minus x minus 2 on both sides, this x plus 2 and x plus 2 will cancel out. Negative 10x minus 20 divided by x square plus 3x equal to 0. Again, a fraction equal to 0, therefore numerator should equal to 0. This implies negative 10x minus 20 equal to 0. This gives us x equal to negative positive 20 divided by negative 10, 20 by 10 minus, which is negative 2. Right. Now to find, now this is the x coordinate of the point where the slanted asymptote and the function intersect. To find the y coordinate, we can substitute x equal negative 2 in either function or slanted asymptote, because at the intersection point they both have the same y coordinate. Easily we can substitute this in the slanted asymptote. Right here, when you substitute x equals negative 2, we get y equal to negative 2, positive 2, we get y equal to 0. So I'm gonna note that down too. For that I'm gonna erase this part. 0, x equals -2, y equals 0, intersects -2, 0. Alright, this is the point, -2, 0. I'm gonna erase this part. Now we can do the sign analysis. -5, negative x equals -3, 5, -3, 3, -2, 0, 2. Is equal to 0. This is the vertical asymptote. This is infinity, and -3. This is infinity. This is equal to -2. X equals -2. It is x-intercept. This is 0. This is 0, 2, 0, x-intercept. These are x-intercept. We have 3 x-intercept, these 3 points. At these points, these are vertical asymptotes. I did the sign analysis. I write that for you, but substitute a number. You know how to do it now. This is in this region, it is less than 0, greater than 0, less than 0. This is what I got. Greater than 0, this region, it is greater than 0. Okay, now we can do the graph according to this. We have vertical asymptote at x equal to 0, means y-axis is a vertical asymptote to let's do x-intercepts. -5, 0, -5, -2, and +2. These 3 points are x-intercept. That means graph definitely go through these points. There are no y-intercept. Now according to checkpoints, now there is another vertical asymptote, x equals 0 and x equal to -3. Graph never intersect the vertical asymptote, so leave it as open circle. Left to -5, it is less than 0, come in this direction. Right side it is greater than 0, that means it definitely graph should go like this. And where it is getting closer, that's the other thing. When it has a slanted asymptote, let's continue up to here. It has a slanted asymptote. Let me do the slanted asymptote like this. Equation of the slanted asymptote is y equal to x plus 2. Therefore, for big values of x, this is getting closer and closer to this line. It never intersects this. How about right side of -3? It is less than 0. That means it should come in this direction. This point you should be careful. It has x-intercept at -2. Also, the graph intersects the slanted asymptote at -2, 0. So you don't have to do it separately. This is because when you move your graph through -2, that is well agree with that. It intersects the slanted asymptote at -2 and getting closer and closer to this is the y-axis. I write it on this side, y. Okay, now right side of the y-axis means right side of 0. It is greater than 0. And it is right side of this. Left side it is greater than 0, right side it is less than 0. That means it should come like this, and it should go through this point. Now it is clear. Okay, it should get closer to this for big values of positive x. Right? The graph should look like something like this. This is not a straight line. Okay. Alright. So practice this question too. Again, this is an example where the graph intersects the slanted asymptote. The previous one, it has a horizontal asymptote and it crosses the horizontal asymptote. Right. So if you could do these two questions that I discussed, you are good to go. As I said, if it is not clear, don't give up. Get a pen and paper, write it down, go through the video again, write down these steps, then follow those steps. Then you may pause the video and write down steps. Once you get that, do a couple of times, guarantee you will get it. Right? If you just watch and turn it off, you don't get it. If you do not understand, I believe many of you guys did this type of questions in high school. Those who doing this for first time, do what I ask you to do. Do few times. Alright, I'm gonna erase this and I move on to some question from section 2.5 and 2.6. This question is from the book. It's on page 246, example 6. Okay. Now, before I do this question, let me remind you something. Now, so this is a straight line, and say this is fx. We name this as fx. This go through these points. We can find the equation of line, but that is not the point. What I want to remind you, finding the slope. To find the slope, you find two clear points, two points with clear intersection. Now, if you select these 2 points, or you may select these 2 points or these 2 points, right? Whatever very clear the coordinates. Now, does it matter if you pick coordinates on the positive side or negative side? No, we should get the same answer. If you let's try how you write the slope. Slope is rise over run. Now, if you consider these 2 points, rise is this, run is this. Rise is always y direction, run is x direction, right? The sign we take it by looking at the graph. You remember what I told you in class? When you move your eye from left to right, if you see the graph is going up, it has a positive slope. We already know, therefore this has a positive slope. Rise y coordinate difference means this side 2, this is positive side, 2 divided by run is this here, 2 to 4, again 2 units, which is 1. Now, do we get a different answer if we get the slope from here? Let's try. Same line, it cannot be different. looking at the line, the slope should be positive. Rise is this, y coordinate difference. Now once we decide the sign, do not worry about sign anymore. Just look at the rise, magnitude of rise and magnitude of run. Magnitude of rise is, we want to go from here to here. Rise is 2 units. The run is again 2 units, which is 1. Same, we get the same slope, right? The only other thing is, if you want to find function value, say for instance f of 0. F of 0 means when x equal to 0 at this point, when x equal to 0, what the function value? Function is this line. Function value is -2, right? I'm writing just an example. So just one more. When x equal to 3, the function value, how we write that? F3 means when x equal to 3, what is the function value? When x equal to 3, to find the function value, we go to the function, we go to the y-axis. This gives us the function value, which is 1, right? I just remind you how to find the slope and the function value, because we need this for this example. Alright, let's go to the question. This question is with derivatives. You may wonder why I remind you slopes and function values, etc. You will see that we need them. This is example 6. In page 246. It gives you a graph. I don't know if you could see this. I try to show you. This is the question. You have the book. Look at the graph. I'm not going to do the graph. I just write the values. The question is asking you to find. Okay, it has 3 parts. In part A, it's running out of ink. I'm going to use it. Let me use this black marker. Hx equal to fx dot gx, find h dash x, h dash 1. Now this is a product rule. Why we using that? It's asking us to find h dash 1. This is given. If hx equal to fx times gx, find h dash 1. To find h dash 1, first we have to find h dash x. Let's find h dash x. H dash x means derivative of hx. We have to use the product rule. Fx g dash x plus gx f dash x. Okay, we want to find h dash 1. So h dash 1 is equal to f1 g dash 1 plus g1 f dash 1. So this is now, okay, now this is why I taught you, I remind you about slopes and function values. Now open up your book, go to page 246, the graph I showed you. This, I'm gonna find these values, derivative values and function values from there. Derivative means what? We discussed that derivative of g dash is same as the slope of g at 1, right? That's what it means. Okay, let's see. F of 1 means it gives you two graphs when x equal to 1. f1 is 1. I'm taking this value from the graph. G dash 1, go to the graph gx and see when x equal to 1 what happened to the graph. You see a straight line. Let me see if I can, this graph, when gx is this, when x equal to 1, gx is -1, that is true, but g dash x means the slope of the graph when x equal to 1. The slope of this line anywhere is the same. From here to here, it's all, the slope is 1. Take the rise over run, rise and run, right? This is exactly the thing I showed you before, right? So it is +1. G dash 1 is 1 plus the other values I substitute. G of 1 is -1 I showed you, times f dash 1 again -1. This is 1, negative times negative, positive, +1. This is 2. Clear? Alright, I'm going to part B. Mx, for the convenience, if you comfortable with this, you may just eliminate x, neglect x, and write m equals f over g. This is same as mx equal to f of x divided by g of x, right? Now again the question is, if m equal to f over g, find m dash 0. 0. So now this is a quotient, and we want m dash 0. In order to find m dash 0, first we have to find m dash x. So okay, if you, maybe some of you new to this, I write x here, and x here. That means all these are functions of x. So m dash x is a comma. I'm writing the quotient rule, gx times dash x minus fx times g dash x divided by gx whole thing square, right? Now we want to find m dash 0. That means g0 f dash 0 minus, simply substitute x equals 0 in this equation, f0 g dash 0 divided by g0 whole thing square. Alright, now substitute values. G of 0, you find it is negative 2. F dash of 0, I'm trying to show you here. This one going up and down, it comes to a corner. I try to put it on the board. It is this, you see, this line is fx, right? F dash x means derivative of this, means the slope of this line. Slope of this line, it is like 2. This is like negative 1. But f dash 0 means derivative at this point. We learned this. Derivative of sharp points is undefined, right? Therefore f dash 0 here does not exist. Undefined or does not exist. Once this one of them does not exist, the whole thing m dash 0 is undefined. You may plug in these values. This is minus 2 times 2 divided by g of 0 is negative 2 square. Doesn't matter. Once this does not exist, means if any of these values not existing, the whole thing does not exist. DNE. Alright. Okay. I'm gonna do part C. If R equal to of g of x find r dash 0, r dash of 0, right? Rx, the function Rx is given, it is a composite function f of g of x. Find r dash 0. To find r dash 0, we have to find r dash x. For composite functions, we have to use the chain rule. It is f dash g of x multiplied by the derivative of g with respect to x, which is g prime x. Now we want r dash 0. Substitute 0 for x, f dash g of 0 times g dash 0. G of 0 g of 0 is negative 2 f dash g of 0 we found this is negative 2 times g dash 0. G dash 0 is negative 1. Now f dash negative 2, derivative of f at negative 2, that's what this means, derivative of f at negative 2, it is positive 2. This whole thing is positive 2 times negative 1, which is negative 2. Alright. Okay, there you learned how to do these questions with given derivatives in the form of graph, right? Now I will do a question from section 2.6. I'm gonna erase this. This is in page 256. Example 7. Alright. This question. So then it would be easier for you to find this. It has a table here, right? It gives you x value, fx value, corresponding gx value, corresponding f dash and g dash. See, this question and previous question, they are kind of related. Means the previous question, fx, gx and f dash g dash x values we found from the graph. Here they give those values in the form of table, right? This question is easier than the previous question. Let's do this. Again, the question is, if hx is equal to f of g of x, find h dash 0.123. Now h of x is defined as f composite g of x, and we have to find h prime 0.123. Now in order to find h prime, we have to find h of x first. So let's find h of x, h prime of x means the derivative of h with respect to x, h prime x or h dash x equal to differentiate this again, since this is a composite function, we have to use the chain rule. First we differentiate f with respect to x, we get f dash g of x, then first we differentiate f and then multiply this with derivative of g with respect to x, which is g prime x. Now we want to find h prime of 0.123. Substitute that for x. H prime 0.123 equal to f dash g of 0.123 times g dash 0.123. Okay, now g of 0.123, g prime 0.123 is given in this table in the book. Substitute those values, we get f dash, substituting for this 0.985. Multiply by g prime of 0.123, it is negative 246. Okay, f dash 0.985 again from the table, we get 0. Let me see what it is. 0.504 times this number, negative 0.985. 246. Multiply these two, we get negative 0.123984. Alright, so those are the questions I wanted to cover today. Okay, you may find last questions from section 2.5 and 2.6. This is from section 2.6. This is from 2.6. You find these are kind of easy, but if you just with the knowledge of derivatives, it may be a little bit tricky unless you see at least a couple of questions. So now you have questions, so do them over, especially those couple of questions I did at the beginning of this session, of this video. Do them at least couple of times over, right? Then that covers a lot of things. So if you have any questions, email me. Alright, take care guys.